Of Azure AZ900. So this section we're going to talk about some Azure Core Services. This whole section, part two, is all about core services, and it's going to be 15 to 20% of the exam. So in this section, we're actually going to be talking about core architectural components. Those are regions, availability zones, resource groups, subscriptions, management groups, and Azure Resource Manager. I'm going to kind of break this up a little bit so that it's a little bit more logical in its design, but this whole process around how do you design and build is what we're going to be talking about today. So region and region pairs, the big thing to remember is that each Azure region features data centers, right? And they're all connected to each other by what's called a latency defined parameter. What they mean by that is that as you're going through and you're hooking up your data centers, there's a certain amount of time it takes the information to get from point A to point B. So when you're a low latency defined network, you're looking at something that you can talk to each data center in about 10 milliseconds, 20 milliseconds, somewhere in there, and really super low. And that's the important part, is if you have three data centers and they all can talk to each other really super fast, then they're what's called dedicated regional low latency data centers, and they're a region. Sometimes you might actually have a pair where two regions are paired with each other. So if one goes down, the other one picks up, or you can actually use that to do some really interesting staging. The big reason you want to do this is for failover, right? And business continuity, disaster recovery, and also not only that, resiliency, but making sure that your applications can actually grow as they need to. Right, so this design ensures that Azure services, basically are always within region, within reason, within the SLAs. The regional pairs, though, are really what's interesting. When you have two data centers or regions within the same geography that are paired together, you really want to do this so that you can actually do your updates better, you can do your planning better, you can do performance better. The only one that doesn't have that is Brazil South, and I'm not too sure you're actually going to get called out on that on the test. But just make sure that you understand that there are regional pairs. There's just this one exception hanging out there. But the big key behind this regional pair is that it's called serializing updates and planned maintenance. What they mean by that is that if you actually have application in both of these regional pairs, these paired things, you can actually go and do an update in one and have all your traffic sent to the other data center, and then vice versa. Update your second while the first one takes over. And you can actually improve your performance and your failover capability in the region in the event of a disaster, taking out the whole data center, or someone accidentally cutting the fiber optic cable or any other thing. But the idea behind that is that you can actually get some really good updates going, and you can do a lot of good processes with this as a big part of your disaster recovery business continuity process. So in that regional pair, you're going to use tools to manage it. And that big tool is going to be the Azure Traffic Manager. And you can use that to distribute your internet traffic to all your different regions. And you have that tool. That's your tool. In comparison to availability zones, which are physically separate, the regional IP pairs can be located within 300 miles of each other. That's also kind of another important idea behind that. So understand that your availability zone is a physically separate data center where your paired region or your region is basically a larger group, a larger set of data centers, and that paired regions are within 300 miles of each other. Microsoft recommends that organizations configure your application to be cloud native, in that you have a disaster recovery plan, you have BCDR, and that your application is spread across one or more availability zones and one or more regions or regional pairs. The other thing that makes this really, really good for you from the testing standpoint is that utilizing Azure's isolation and availability policy is a great way to benefit, right? So if you have one region fail, another region will automatically step in, and your application will automatically step in. And that's part of the brilliance of the cloud, is that you can actually just program for this. So no more risk management, no more weird cold sites or other kind of archival sites that you need to have, no trying to wait for Iron Mountain to come and deliver all your tapes to some weird site somewhere across the state. And then you just have it automatically set up. So if one goes down, boom, another one picks up. And that is a great way of dealing with all of your business continuity and disaster recovery processes. The big thing about availability zones is to make sure that you understand those are geographically separate zones within an Azure region. So that's the big one. So availability zone is your big box, your region is your smaller data center or clustered data centers within a geographical area. So availability zones, geographically separate. Each availability zone has its own power, network, and cooling. You can actually deploy virtual machines across availability zones to protect the application. Again, that's part of your disaster recovery, your resilience. That's part of making your application a little bit more cloud native, and that you are taking your application and spreading it across 3 or more availability zones in different regions. And that's a big part of your architecture. The big thing about this, though, is that there's a plethora of services that work with availability zones. You don't need to remember all of these. You just need to know that virtual machines, databases, gateways, application gateways, data, SQL databases, there are things that actually work, domain services, so that you can actually literally stand up your entire organization in this, and that it's going to work with most of your services along the way. Resource groups. Now, these are an interesting logical container, right? So think of this like a bucket, or think of this like a folder, right? You're going to put all of your resources in logical containers in Azure. And that is a really good way of managing things. So if you have all your databases that run on a web application, you would probably put that web application into one resource group. So if you have a web application and a database and an Active Directory for people being able to sign up, that would be one resource group. Resource groups hold related Azure resources that are part of a larger solution. This can include your failover, your disaster recovery, or your business continuity measures, right? So you can have that resource group spread across 1 or more availability zones or resource group or resources, regions, and all those other things. They can host all the resources that compromise the solution, and the solution is your whole application. Right? Or they can host just resources that need to be managed as part of a group. You may have a different what's called a life cycle for databases versus web application. And you can actually break those resource groups out by life cycle. So you have a big resource group for your application, and then you can break each one of these out into smaller resource groups based on their life cycle or workflow or needs or compliance issues or anything else that you have to deal with along the way. All right, and then Azure administrators have the option of allocating resources in resource groups based on their needs. So you can actually really logically design your resource group almost like you would an org chart. And it's an interesting way of going and approaching how an application works. We don't usually plan it looking like an org chart. So resource groups, so big things to remember is that an Azure resource is any server instance that you create. It's anything that you do, any service, server, anything. That is a resource. A resource group is just a group of related Azure resources. In general, resources are part of a resource group that share that same life cycle, that same update, patching, management, CI/CD, anything else that they all have to do together, then this is how you would want to deploy it. Right? When you create a resource group, you can specify a region, and that region is where all the data about that resource group is stored. However, resources themselves can be in any Azure region. So you can take your application and spread it across multiple regions and across multiple availability resources, and they'll still be in one resource group. Each resource must be in one and only one resource group. You can't have a resource in more than one resource group at a time, and that's where that org chart process comes in place. You can move a resource from one resource group to another, and that's easy, just drag and drop it. You can add or remove a resource from a resource group at any time. So if you go ahead and you have version 1 and you have version 2 of your application, you can literally just go ahead and delete version 1 once you've migrated everybody over to version 2. Not a problem. You can also arrange your resources any way you want. You can do it by department, country, application, resource type, any combination of those. It just all depends on how you need to organize your data and your applications. So in summary, these were core services. These are really big core services. These are Amazon regions, your paired regions, your availability zones, and your resource groups. They're not going to be asking you, tell me how many data centers there are in Virginia. The big thing to remember is that there's probably about 53 data centers that you can actually work with and use and process data with. But other than that, this is that section of the test. It's all about regions, Azure regions, availability zones, and resource groups. So thank you very much for attending this lecture, and I will see you in the next one. This is part 2, section 2. We're going to talk about subscriptions. So the interesting part about Microsoft subscriptions is that you can have more than one. So a subscription is basically an agreement between you and Microsoft to use product or service, whether that product is Azure, whether 365, Office, or Dynamics, or It can even boil down to something as simple as your SharePoint, software licensing, or anything else. It's just basically either pay per seat or cloud-based resource consumption. It's just the whole process of setting that up and subscribing to specific things that you want to do. So what makes subscriptions really notable, and the reason why we're kind of pulling them out as a separate thing, is that subscriptions are actually have two different pricing models and two different ways of looking at them. So you can buy a software as a service product like Office 365, which a lot of people do, or Dynamics 365, that whole 365 subscription service. That's one subscription type that you can use and you can manage through your Azure account. Then you can actually buy specific Azure services, software as a service process, PAAS or IaaS, depending on what you've got. But the big thing to remember is that your service subscriptions, anything your software as a service or buying a product like Office 365 or Dynamics, is a per seat or per client cost. Azure is resource consumption, so you're paying a resource subscription fee for using that product, and that's the big one, right? You are either doing software as a service and you're paying a per seat license, or you're doing Azure directly as resource consumption, resource subscription to that particular product. So remember, that's the bit, right? So organizations, you can have multiple subscriptions to different products. They don't even have to just be completely Microsoft products. You can have Oracle subscriptions and other things that go along with that inside of your Azure. But again, if you have something like Oracle, you're paying for it. Licensing in Azure, though, can be per seat or per client for those software as a service offerings that you've got. But what's interesting is that for platform as a service, Microsoft's built all the licensing into the service model pricing, so you don't have to buy a separate license for that. So that's a good way for you to acquire more licensing without having to pay that huge upfront cost. For infrastructure as a service, though, you have to bring your own license, and that can be kind of pricey, but it's great if you've already made that investment in licenses already, right? So that's why you can bring your own license to this, and you won't have any big deal. So if you have all these licenses you've already paid for, you can bring them into Azure and use them. The other thing to remember too is that some of the Microsoft provided virtual machines will have trial software. So if you're using something like SharePoint or something else, those VMs will have the trial software, and when that trial expires, you'll have to go ahead and either purchase the software or stop using it. It's kind of up to you depending on how you want to go about it. So again, when you're walking away from here, you want to have the idea that subscriptions are multiple offerings, right? And multiple cloud offering subscriptions can use the same as your Active Directory tenant that acts as a common identity provider, so that's handy. And then a central Azure tenant that contains all those synchronous accounts can actually help you do not just identity as a service, but help keep track of how many clients and per seats and systems that you've got running specific software. So if you need an audit, this is one way of going through and using that central Active Directory tenant for that process. So the things to remember about subscriptions, again, right? Essentially, subscription is the ability to use and pay for a service, whether that's software as a service or platform or infrastructure or whatever you're using. An organization can have multiple subscriptions that are managed through the Azure portal, right? A subscription can have multiple different kinds of licenses. You can have a per seat and a resource consumption doing the same thing, right? So you can have resource consumption on SharePoint, but you can also have some specific parts of that are per seat because it's kind of pricey. All right, license can be assigned to individual user accounts, which is important. You don't have a big group license. You have licenses, especially per seat, to individuals, named individuals. And then user accounts are stored as your Active Directory tenant. And again, that's help you when you get to auditing or finding out how many seats you're actually using and all that other process. So that's really it for the subscription model. It's really clean. It's a very quick thing to pick up again on that. Essentially, just remember that you're either consuming or you're paying per seat, and Azure manages both of those for you through Active Directory with a whole lot of auditing enabled on that as well. So I will see you in the next lecture. Section 2.3, we're going to talk about resource management groups. So resource management groups are kind of an easy way of just organizing all your subscriptions in one spot. So it's efficient, it's organization, it's just making sure that you have everything you need so you can manage your access, your policies, and then all the compliance rules that we need to follow for any kind of subscription that you have. And you can do this by creating Azure management groups. So these resource management groups, you're going to organize all your subscription into management groups to make sure you can apply whatever governance you need across whatever the management group you need to do. So your HR and your payroll are going to have a different set of governance and management than your ServiceNow ticketing system or your Dynamics 365 or even your Office 365 process. You want to be able to push those down, and the easiest way to do it is just by management group, logical hierarchy and organization. So any subscription within a management group is going to inherit conditions applied to the whole group. So you can do global or you can do local manage subscription policies along the way. So whatever subscriptions you have, management groups can give you enterprise level process, and so you can scale these out really easy. So let's say you get acquired or someone acquires you or you acquire someone else, you can push down all of your policies relatively quickly and relatively painlessly. So subscriptions within a single management group have to trust the same Active Directory tenant, and that's the big one to remember. So whatever subscription you've got has to trust whatever Active Directory tenant that you've got in that entire process. So resource groups can be huge. You can have 10,000 management groups under a single directory, which is like crazy huge number of people to support, or just management groups to support. So that's going to give you not just your department and organizational level, but that's going to give you your security groups, remote access policies and groups for depending on which, and you can even break it down into geographic if you want, depending on how you want to do it. Management tree can up to 6 levels of depth, so that's a big one. You can only go 6 levels down, so you can have the organization, acme.com, and then under Acme, you can have legal and payroll and accounting and all the rest. And then underneath that, payroll, you can have your contractors and you can have your regular people, the full-time employees. You can really break this thing out nice. Again, it's going to be an org chart looking kind of thing. Each management group can have children and have many children along the way in terms of that org chart. And again, that single hierarchy in each directory, you can subscribe and manage and do all the policies and everything else. So again, if you're used to Active Directory, if you've ever worked Active Directory before, this resource group is going to look exactly like it. So definitely not a problem there if you're comfortable with it. The root or the admin management group is top level for each directory. So you only have one root place. And usually that's going to be your company name, so acme.com or whatever you want to call it. And then your management groups and subscriptions are folded up underneath that. Root management group, that's where your global policies are going to apply. And that's global. That's everybody in the organization has this same policy. But you may have an information security department that has a different set of policies. We already know human resources is going to have their own thing. So they're going to have their own policies. So when you're doing root management, you're looking at the entire organization in whole in terms of policy and compliance and being able to push those down, knowing full well that each individual unit underneath that is going to have their own set of policies or rules or compliance things that they need to do. You'll need to make sure, though, when you do this, that your global Active Directory administrator will be elevated to user access administrator for this root group initially to be set up. You may want to delegate that off to someone else along the way. But when you're doing your initial setups, you want to make sure that that is all taken care of so that your admin can take care of user access. So in your resource groups, the things to remember, and these are the big ones to remember by default, root management group's display name is tenant. So you have to change it over to your own name. To change the display name, your account must be assigned to the owner or the contributor to that root account. So you actually have to own it to change it. So if you're going to call it acme.com, make sure you have the ability to do that. The root management group can't be moved or deleted. It's just what it is. It's the base of your organization. So you're going to have to cope with that in terms of not being able to move or delete, because it would be horrible if you deleted the entire root of the organization. All of a sudden, there wouldn't be one in Active Directory anymore. So it's kind of a safeguard and a security safety process there. All subscriptions and management groups will fold up underneath the root management, and that's a big thing to remember because it's very org chart looking. And then in the SDK, if you're working in a software design development kit, the root management account or tenant root operates as a single management unit. Then all resources in the directory fold up to the root management. That's a big one to remember. So that whole process of that root account that's where you're setting your baseline understanding of the organization. New subscriptions are automatically defaulted to the root management when created. So if you're making a new Office 365 subscription because you never had it before, it's going to go right in underneath the root management account. So you want to make sure that if it needs to be moved someplace else, you've got the organizational setup for that and you know where it's going to go. All Azure customers can see the root management group, but not all customers have access to manage it. So that's essentially the thing, right? We can all see it because we have to be able to see it in the hierarchy, but that doesn't mean we can manage it or change it or use it. We just have to see it. You can't mask that from the users, especially in your organization. Everyone who has access to a subscription can see the context of where that subscription is in the hierarchy. So if you have an Office 365 subscription and it's 3 levels down, everyone with an Office 365 subscription is going to see that, but they're also going to be pushed by that policy, the OneDrive and the email and all the rest of it that comes with that inside that hierarchy. So they'll be able to see whatever's in OneDrive. And that's a really important thing to note. It's just where it is positionally in Active Directory and in the hierarchy, but make sure your policies cover how that's going to run. Azure AD group administrators are the only ones that can elevate themselves to gain access. So that's a big one, right? So understanding that group policy and how that group system works. Once they've got access, the global administrator can assign any Azure role to anybody else along the way. So resource groups. So just remember that access and policies assigned to the root management group all apply to all the resources within the directory. If you're buying a new service that's going to show up in your Active Directory, and you really need to make sure that everybody understands that it all has to be underneath that one Active Directory group account so everybody knows what they've got. User and access policy assignment should be a must-have only at this scope, so they must have it. You may want to go with least privilege, which is the same kind of concept, but a little bit different. Must-have is the only people that must have Office 365 via the web, or people that must have Office 365 as the desktop client, because there is a difference in the price. So if I'm just using the web client, it's like $6 a pop. If I'm using the desktop client along with my Office 365, I think it gets raised to like $12.50, $13 a seat per person. So that jump of $5 or $4, $5, it can be expensive, especially if you're dealing with hundreds or thousands of people. So again, it's that must-have in scope that you kind of need to think about when you're doing this, because pricing model is different when you're working on that per seat, per license kind of thing. And that's why resource groups are good. So that covers the real quick lecture on resource groups. And I will see you in the next lecture. Point 4, part 2, and we're going to talk about the Azure Resource Manager. So the Resource Manager is essentially your deployment and management service for Azure. It covers everything in Azure. It provides you all that management layer that enables you to create, update, and delete anything in your Azure account. So this is like the one account you really want to make sure you've got secure, where you're going to use multi-factor authentication. You want to use a really good password. And you don't want to use the password 1, 2, 3, 4, 5, 6, 7, 8, or like Toto, Wizard of Oz. I mean, you just don't want to give this one away, because if you lose this one, you lose everything. And you can use all the management features. You can do access control, locks, tags. You can secure your organization. You can secure your resources after deployment. This is like the keys to the kingdom. So you really, really, really want to be aware of that. So there's some new terms to know in this section, especially as you kind of go through what is an actual resource. So a resource essentially is that manageable item available through Azure. That can be anything. That can be storage account, Office 365. It can be anything along the way, right? Anything you've got is a resource. A resource group is that container that holds those related resources, whether it's by life cycle, by use, by department, however it breaks out in your org tree, or however you want to go about it. The resource provider is the service that supplies those as your resources. So, Microsoft, there's other ones out there probably that do resources as part of the process, especially if they've got marketplace VMs. So you may see some Oracle would be a resource provider. You could hook to Oracle Web, the Oracle Cloud, and other things like that. There would be a secondary resource provider off of that, and you may want them in their own resource box. Resource management template, and this is, you don't need to know what JavaScript object notation is. You just need to know that you can get some resource manager templates to help you out, and those are in the JSON format. Now again, it's just one or more resources. It's a definition. If you go higher on into this, you'll learn a lot more about how those templates are put together so you can do this. But for right now, for this test, it's just good enough to know that there's a JSON JavaScript object notation resource manager template out there that you can use. And then declarative syntax. This is another one that's kind of programming. Here's what I want to do. Here's what I want to create. Here's the task I need to accomplish without having to write any of the programming commands or anything else. The resource management template is a great way of helping you build that without being a programmer. Just in case you need to, if it's not something that if you're going to move on into administration, this is something good to know, that these templates can be auto-constructed. You can really just help out and do a lot of things with that all on your own. And if you go into template deployment, you can get a really good overview of it, but that's not really what you're going to see on the test. You're not going to be deploying templates for users. You just need to know that it exists, and it's a good option to have. What you can do with the resource manager is basically everything, again, as we described, this is the keys to the kingdom. You can manage all your infrastructure. You can deploy and manage and monitor all of your resources. You can do it as a group or you can do it individually. You can redeploy your entire solution should you choose to. You can define any dependencies. You can apply access control through Azure role-based access control natively integrated into the management platform. You can also push this down to your Active Directory tenant to run your entire organization, so you can make policies for access control. You can apply tags to resources. Now, tags are really cool. Tags are really something you're going to want to get into, because if you know how things are named, like Denver VM1 or Denver website core or whatever you want to do, these are naming convention and tags that can be really helpful, especially if you get into data mining, right? Or you just need to build an org chart across that. You can also clarify your organization's billing by viewing costs for a group of resources sharing the same tag. Tags are important, so we'll cover those a little bit later as we get into this, because that's something you're really going to want to know about. Now, these things are important. All the resources in your resource group should share the same life cycle. In other words, they should all start and finish about the same time. And by the mean life cycle, if you have virtual machines that are on the monthly Microsoft update, you would want all those in that same resource. And this is just the Microsoft convention, right? Other people may want to go that this is my web server cluster, and this is my VM cluster, this is my database cluster. They may not see it as a life cycle thing. They may see it more of a function thing. Right? So depending on how you want to do it, but the idea is that they're all serving a purpose and they all have a relatively same life cycle, and that each resource can only exist in one resource group. You can't have this one database and multiple resource groups. So if you're going to break things up, if you have a payment database and you have an HR database, you don't want those to be in the same resource group. You want them in two different ones. You can add or remove a resource to a resource group anytime. You're not limited on that. You can move resources around from one group to another group, but just remember it can only be in one group at a time. The resources in a resource group can be located in different regions. So you can move or have your HR database in Washington, D.C. and your customer database in San Francisco. No one's going to care about that. That's not a problem. When you create a resource group, you have to provide a location for that resource group. So it either has to be, it has to be in Virginia, or it has to be in California, or it has to be in Ashland, Oregon, or wherever it is. So you do want to identify where that location is inside the resource group. Resource group scope, the scoping of this is big, because remember, this is the keys to the kingdom. This is everything. So resource group can be used to scope access control for administrative actions. So that's big, right? You can limit access to administrators for their specific group. So if I'm in Washington, D.C., and you just want me to manage the Washington, D.C. cluster, then you can restrict my access to just that. I will not have global access to all of Azure. That's important, because then once you can start breaking out the hierarchy, you can actually start creating and defining those security group policies on who should be responsible for what. You can apply tags to the resource group so that you can identify things a lot easier. It makes it a lot easier to data mine. If you use something like the dev tag for everything that's in development, then you can actually go through and see and track on how many times the development servers come and go and how often they're used inside the system. A resource can connect to resources in any other resource group. Right? It's common that you're going to have one resource group of web servers and another resource group of databases to feed it. A firewall or a system load balancer is going to be part of one group, and it will connect to all the other groups along the way. And that's a great way of organizing and architecting things. When you delete a resource group, all the resources in the group are also deleted. So if you delete that resource group for web server cluster, all those resources go away. That's important. Right? So you want to make sure that you don't accidentally delete stuff. I would actually try to put a key in there that will make it harder for me to delete things. You can actually go about and set up how Azure Resource Manager orchestrates those deletions. And you definitely want to go into Resource Manager on this one. When you get into architecting or you get into developer, you really want to pay attention to this. You can deploy up to 800 instances of a resource type in a resource group. So I can have 800 databases or 800 web servers or 800 Active Directories, although I don't think I'd want 800 Active Directories, but I can have an Active Directory per group, per system, per place, right? And have those all in one resource group. So that would work. So Active Directory in DC, Active Directory in Ashland, Oregon, Ashland, and one in my main core office. Some resources can exist outside of resource group. So I can have stuff over here on the side. Really watch for those, because those can be untracked or unmonitored. And you really want to make sure that you're controlling spend by making sure that resources always end up in some kind of resource group. And that if you have stuff that's just appearing on the side that's not part of a resource group, that spend may not be tracked. And you really do want to make sure that you are making sure that however you've deployed your solution, that everything is in some kind of container so that it's easy to see, easy to track, easy to monitor, easy to control spend. To create a resource group, just go to the portal. You can do it in the portal, PowerShell, Azure command line, or just a simple template. So there's lots of ways of doing this and making it happen. One of the other things that's really important to understand about your resources is that there's metadata, right? So there's data about the resource itself. So resource stores metadata about the resources. So that resource group knows what's going on with that system, how it was created, when it was created, who it was created by. So when you specify a location for your resource group, you're also specifying where that metadata is stored. And again, that can be really handy, especially for data mining, tracking spend, anything else that you plan on doing with that resource. There's only one thing that's the hitch to this, right? If a region's resource group is temporarily unavailable, you can't update the resource group because the metadata is unavailable. So if the metadata is not available, you can't update the resource. So if there's something going on that's blocking or taking that system down, if that region's unavailable, you won't be able to update the metadata. You won't be able to update the system itself. So that's important to remember. Resiliency. So Azure Resource Manager is designed for resiliency and 24/7 availability. If you really want to get into the control plane operations, you can do it programmatically through software using the REST API through management.azure.com. And again, you can be distributed across regions. You can have one resource manager for DC and one resource manager for Ashland, Oregon, and then the main global one wherever you're at. It could be distributed across availability zones. It's not dependent on a single logical data center, and it's never taken down for maintenance activities. So you'll always have your Amazon resource, your Azure Resource Manager, no matter what. The resiliency applies to services that receive requests through the Resource Manager. So you'll always have access to your crypto keys and a bunch of other really critical services along the way. So if something goes down, your company will always be operating. So that's it for the Resource Manager. You can kind of tell that it really is the keys to the kingdom. It's the one thing that you really want to make sure you have taken care of and you have absolutely covered for those accounts. Don't use bad passwords, use multi-factor authentication, do all the right security things with this, and make sure that you do understand those resources and that this is basically a 24/7 service that is global in nature, and you can break it down into smaller operational chunks just to support your organization and your organization's needs. And that's it for this lecture. I will see you in the next lecture. Section 2.5, explain Azure resources. This is a really kind of just a quick overview of what kind of resources go by what deployment model. So basically what it is that in Azure, a resource is anything that belongs to Azure, whether it's a virtual machine, a virtual network, storage accounts, your Office 365 account, any of that is all considered a resource. And it's something that you either use, consume, or configure, or something else along the way. Now, there are different Azure resources based on the kind of deployment you use, whether it's infrastructure as a service, whether it's platform or software as a service. So they kind of break this up a little bit. And that if you're doing infrastructure as a service, then those are user-managed raw resources. These are things that you build. Those are going to be your virtual machines, storage, just raw storage, raw networking. And these are all things that you need to configure along the way. From there, you go into platform as a service. Now, platform as a service is a little bit different because then you start getting into your bigger managed services. You start getting into Azure SQL, where all you're worried about is the data. You don't really have to worry about configuring, updating, and managing and maintaining that SQL server. Azure Files, same kind of idea, system message block file share service. So now you have a Windows file server, but now you don't have to worry about any of the network attached storage. You don't have to worry about disk failure. You don't have to worry about backups. All that's maintained and managed by Microsoft. And then data services, and these are really kind of neat because you don't really think about data services being a platform as a service, but it really is. So you have things like your machine learning and your analytics and your cognitive series that go along with that. And that really what it is that you are supplying some data, but Microsoft is providing the resources on that platform to do some of the modeling, to do some of the other things that you would want to have done with that along the way. And then finally, you've got software as a service, and these are just things you use, right? These are a per client, per seat kind of thing, whether that's Office 365 or Dynamics 365. That's basically everything's managed by Microsoft. The only thing that's downloadable is you may have the desktop version of it for a little bit more, but even those have service software patches pushed down by Microsoft. If you've ever used Office 365 with a desktop client, you'll see that it sometimes validates or verifies or goes through and just automatically updates all of your client software. And none of it has to be managed or maintained by you or your company. So in summary, really, you have your core Azure services depending on the type of deployment used, right? So IaaS, PAAS, and SaaS. And as we go through into the next sections are going to be kind of lengthy because we're actually going to be explaining Azure resources as you kind of go through them, what they are and why they're used. For the intents of this test, you only need to really know the overhead. You don't really need to go in depth or in detail, but it's really good to know all the options that you have with Microsoft services going into this because you will get some scenarios on that. So I will see you in the next lecture. So this is going to be part 1 in section 2.6 of my study notes, but this has to be broken into 2 sections because there is so much to know, so make sure you're catching both. So these are just the Azure core sections, right? These are the ones that you're going to use a lot. So again, it's a lengthy section. There's no real logical way to break this up, and I apologize for that. This is one of the core aspects of the exam, knowing at least peripherally what the name of the service is and what it does. We're not going to go into in-depth. We're not going to go into configuration or anything like that. It's really more, do you know the name? Do you know the function? Do you know some data migration to it? And all the practice tests that I've seen, there's a lot of things about data migration, especially on database or on files. So make sure you're really comfortable with that as you kind of go through this process. All right. So the first core service, first core resource is going to be the Azure virtual machine. This is part of the infrastructure as a service. It's just basically here, boom, here's your computer, here's your operating system. You can build out this virtual machine to be as many cores and as much RAM as you need that's within reason. And again, this is a pay-as-you-go model. You pay for whatever you get. Very flexible. You can do whatever you need to do with it in terms of that Amazon virtual machine. Then the app service. So this is even a little bit more interesting because you can actually go ahead and do an HTTP-based service for web hosting. All right, so that's the big one. App service, web hosting. APIs, you're going to use your standard web programming languages, .NET, Java, Ruby, Node.js, PHP, Python. The cool part is you can really use all these languages, right? If you take a look at how Facebook is looking for programmers, they're mostly on the Python side, believe it or not. So good stuff, right? But these will allow your web applications to run at scale with ease. Linux, Windows-based environment, doesn't matter. It provides you with all the auto scaling and everything else that you would hope to do. Azure container instances, these are going to be your Kubernetes or your Dockers, right? So Azure Container Instances offers the easiest way to run containers within the Azure environment. So that's really what that is. Just remember container services, Kubernetes, Docker, and again, just being able to run containers and exposing your containers to whatever they need to be done. There's a specific service for that called the Azure Kubernetes service, and that simplifies just the deploying of your Kubernetes cluster. That's a big one. You offload a lot of that operational overhead to Azure. It makes it easy. It's free, so you only pay for the agent node. So that's important. All your management is free with the service, but you're still paying for your nodes. You're paying for that time on the nodes. Then after that, we have our Azure functions. And remember, we were talking about this one earlier on in the lecture series. Functions is your serverless solution, allows you to write less code. And again, this breaks up your program into smaller specific items like, again, functions. So you can do things. So if you have a web parser or you have a parser for this, or you want to take a look at your logs or you want to mine the logs for specific events, then you'd make that as a function as a service. So again, you don't have to worry about doing things. It just maintains less infrastructure and will save you on costs. When you start going cloud native and you start breaking up your program to be more designed around the capabilities of the cloud, and cloud functions is a big part of that. As your batch, so this is kind of neat, we all still do batch jobs. We don't necessarily run all of our credit cards at the same time. If you've ever run your credit card at Amazon, you'll know that you will place your order and sometimes you may wait up to 24 hours to get your credit card actually charged, and it's because they're doing it as a batch. Right, so again, large scale, parallel, high performance computing batch jobs. These are great for training things. They're great for running credit cards or anything else that you would use a batch service for. Azure networking services. So this kind of breaks this out a little bit better into the way that you can hook up all your Azure networking needs. You can use them together, you can use them separately. It depends on what your network engineer wants to do with stuff. So you initially have connectivity services, and these are the things that you connect your Amazon resources and your on-premise resources. So that is the link between your data center and Azure, the connectivity services. So remember that connectivity services is your data center, your on-prem, to the Azure data center. And you're going to use either a virtual network, you can use a VPN, you can use a peering, you can use Bastion hosts, and if you don't know what those are, we'll get to those here in a little bit. DNS, it's a great way of connecting the two networks together. That's a big one to remember. Application protection services, this is neat as part of your security package. You can protect your applications, and that's the nice part. These are all applications or network. So private link, you can just do private links back and forth, and anti-denial of service protection, firewalls, network security groups. Web application firewalls are really good to have and really popular. You may get a question about web application firewalls. And then virtual network endpoints. Where does that network end and where does it begin, and how do you get between the two? How do you route all that stuff? Application delivery services, you can deliver applications in the Azure network. You can use content delivery network, which is great for static content. Remember that. Content delivery networks are really good for static content. So if you have a lot of video, a lot of audio, that's considered static content. If you have a dynamically generated website like WordPress, that will come back. And that content delivery network will always route you back to your home server to go ahead and get that information from you. As your front door service, traffic managers, application gateways, internet analyzers, and load balancers, these are all ways that you make sure you can get your product to the consumer as fast and as cleanly as humanly possible. Network monitoring, we are going to do this all the time. Your network engineer should be monitoring your network for weird all the time. So Network Watcher, Express Route monitors, Azure monitors, or VNet terminal access points. These are all ways that you can network monitor. These are all systems that you can then plug into a log analyzer or anything else. Your security group may need part of this, but your network engineers are going to be and should be in here, at least at the minimal, doing that Azure Network Watcher and making sure that all the traffic flows are good and nothing weird is happening. As your storage services. So this is where you store all your stuff, and data in the storage service can be accessible from anywhere in the world. So it's all web-based, HTTP or HTTPS. It's going to encrypt all the data on it, so you can either use your key management system or you can use Azure's key management system, and you can do some pretty good in-depth what's called fine-grained control over who has access to your data. So these are all good parts of the Azure storage services. Azure blobs, so these are like big files. These are going to be your videos, your audios, your imagery, and they're just basically a big blob of digital data, right? And you can use blob storage to serve those images or documents via browser or stream, and that's a big one. Azure blobs allows you to stream, store logs. It's just good for big files, used for data backup to restore disaster recovery. So again, it just takes a chunk of data and turns it into a big chunk of data, even bigger, called a blob, and that's how it's stored off. It's a great way of storing large files, really great way. Azure Files offers a fully managed file share in the cloud, and it can be either SMB, system message block, if you want to work with other systems, or network file system if you want to work with other systems, depending on how you need to do this, right? You can actually get a peering link for your files between your on-prem data center and your network to the cloud and go that direction using this protocol, right? So you can completely replace or supplement your traditional on-premise file servers. So that's really important. You can do whatever you need to do with it, but it makes a great way of backing up all your local files. And you treat it generally on your network just like any other network attached storage. It's really nice. Azure queues, so we need to talk to other applications sometimes, especially if we're using functions. We'll spend a lot of time sending messages back and forth. And Azure queues is the messaging system. The big thing to remember about this is that it can be anywhere in the world, uses HTTP or HTTPS, and a message queue can only be 64 kilobits in size. So each message can only be 64K. So if you have a programmer in there that's writing 1 or 2 megabit messages, that's not going to work here. It will error out. Azure tables, and this is another one. This is more of your non-relational structured data in the cloud. So this is just like Bigtable or something else that you'd see on that. It's just a table storage, and that's all it is. It's a flexible data set. You use it for web applications, address books, device information. It can be permanent or temporary, but it really is just a table of stuff. It's not anything special here, but it is a great way of storing some really flexible data sets, like a shopping cart for a user at a store. Then Azure disks, Azure managed disks are block level storage. They're managed by Azure and used with Azure virtual machines. So these are the ones you're going to mount onto your virtual machine to be the data drive for whatever you're running on that. So managed disks are integrated with the availability to ensure the disks of a VM are available, and you can usually match them across different VMs if you pick the right kind. And again, it's just to make sure that if you hook it up to more than one VM, that you avoid that single point of failure or that you lose the data that you may need. Now, the Azure Marketplace, this is also interesting because this is a place where you can go buy stuff. You can buy stuff from Microsoft directly if you need a license. You can buy pre-formatted virtual machine templates from software vendors like Oracle and Adobe. But really, it is just two online stores, the App Store and the Azure Marketplace. The App Store contains business solutions, and the Azure Marketplace contains IT solutions. So that's a big one. Microsoft App Source, Business, Azure Marketplace, IT. So there's a lot here, right? And again, I've broken this up into two sections, so you'll have another one here in a minute for data. But the Azure Core Services are something you, again, need to at least know by name and function on the test. So if you're not going to take notes anywhere in this, this is the place you want to take notes, and this is is really the place you want to take notes. So important to know what all these things are. And again, we'll go into data services here in just a second. So I will see you in that lecture. The Azure Data Services, Data Core Services. So section 2.7 of the research notes. All right, so Azure Database and Analytics Services, this is really kind of an interesting way of looking at things in terms of how you manage databases. You can do it as a managed service, or you can do it as something you take care of. And that's the big thing in the flexibility of Azure Database and Analytics Services, is that you get that choice. You can do fully managed, or you can take care of everything yourself. It's up to you how you want to do it. But it really does cover all the different ways of doing data, which is really kind of neat. So the first one, of course, is the one we're going to be all familiar with, is Azure SQL. It's the Microsoft SQL database. It's a fully managed platform as a service database engine. So it's going to handle most of everything you need to do, including upgrading, patching, backups, monitoring. None of that needs to be done by you, but you can make special monitoring packages for this. And again, it would be used like any other SQL database. You can do this any way you want to do it, and it will go ahead and update as you need it to. It includes serverless computing, hyperscale storage, and AI-powered and automated features to optimize all this stuff. It is an amazing way that they've set up MS SQL to be a fully managed service. Azure Managed Instance is a little bit different, right? This is an intelligent, scalable cloud database. So it's the broadest SQL server engine with compatibility, but really, again, you're using this with the SQL Managed Instance process to migrate your SQL workloads to Azure while maintaining all that SQL Server compatibility. So again, it's a fully managed service, but again, it's that kind of, there's your instance, there's your actual table and data and otherwise. Now, SQL Server on a VM is just that. It allows you to use full versions of SQL Server in the cloud without need to manage any on-premise hardware. This is just like what you would use when you're working in your own data center doing your own thing. You can migrate your SQL workloads and complete server compatibility and operation service level. So again, this is where you start taking care of things, right, on that one. Azure Database for Postgres SQL, that is just a different relational database service from Microsoft. Postgres SQL is really super popular. It uses the community edition, and you can build out your database based on that. If you're using this, then boom, there you go. You can scale out from single node to multiple nodes, and you can also migrate your workloads for Postgres SQL and Oracle workloads on the cloud by using this service. Azure Database for MySQL. MySQL is probably one of the most popular open source databases in the world. It is used in everything that I've ever encountered in a lot of ways. In one form or another, it is used everywhere. So having that MySQL Community Edition is actually a really good thing for Azure to have, but you're going to treat it just like any other MySQL installation. You can deliver your high availability, your exhaustive scaling, and all the other things. But you do need to remember it's the community edition on this. So if you have your own edition, if you went ahead and you bought it, and you have the enterprise edition, you will need to bring your version over. Azure database for MariaDB. So this is MariaDB is a relational database service. So again, we kind of use MariaDB as well. It's an offshoot of MySQL. So it actually works really, really well on the same kind of idea. And again, same idea as MySQL. It's high availability, scaling, open source, and it can be a managed service. Cosmos DB, now this is the Azure built-in database. This is their database. It's a fully managed NoSQL database for modern app development. So it is designed for performance. It is literally designed for performance. And you can migrate all of your MongoDB, other NoSQL workloads like Cassandra over to Cosmos DB. You just need to remember that Cosmos DB is the NoSQL version of this. This is the NoSQL version of this one. And again, it does a lot of neat things if you're into a NoSQL database. Azure Cache for Redis provides an in-memory data store based on the Redis software. So this is another thing you do if you want to accelerate your databases. You'll use Redis or you'll use Memcache. So Azure Cache for Redis is basically just that, an in-memory database that you can store data in real quickly and gives you millisecond access to data requests coming in. You can do frequently requested data in this cache to speed up customer service. And the other way I've also seen this used before is if you store customer IDs. So when a store is being built, you'll store the customer ID in your cookie on the computer that the customer is using, and then that ID will cross over into a Redis database for the shopping cart. So that's one of the reasons why it's kind of neat. You don't keep the shopping cart local, you keep the shopping cart on the server. It's just one single pointer, one data point, and usually that will go into a cache really, really, really quickly. Then there's the Azure Database Migration Service, and this is the one that I've seen on every single practice test I've taken for this so far, is that I want to migrate from my local MySQL, what's the best service in Azure that I could use, and do I want to use MySQL for Azure, or do I want to use Microsoft SQL Server? And it depends, right, on what budget and what else is going on inside of that scenario question. So be really aware that there's an Azure Database Migration Service that is fully managed and allows you to just move data from point A to point B. You can use this service. You can use this to accelerate your transition to the cloud. And again, it's simple, self-guided. It's a really sweet migration service that you use. So just know that this exists, and you're going to probably see a scenario question on that. So in summary, you're going to need to know what each of these services are by name and function, again. And many of the pre-tests, they ask for specific data migration scenarios, so you should know what kind of data goes where when it comes to moving things around. And again, with all the Azure services, this is an intimidating section 2.6 and 2.7. So if you need to, just watch this a couple more times and make yourself really, really comfortable with it. Maybe take some notes. And make sure that you do understand that Azure Cache for Redis is an in-memory service, and that MySQL to MySQL is great, but you can go from MySQL to MS SQL. If you have MongoDB, you can go from that to Cosmos DB. And again, it's that whole process along the way. So definitely do take notes on this section if you need to. All right, thank you, and I will see you in the next lecture. Talk about some of the benefits and usage of some of the items inside of Azure. So a little bit more in depth in terms of what you need to know for this section. But again, it's just to describe the benefits and usage of virtual machines, app services, container services, and other services along the way. So the big thing to pull back away from this one is that Azure virtual machines are basically infrastructure as a service. And these are one of the several types of on-demand scalable computing resources that Azure's got. Again, the whole idea is that you choose what kind of VM you need, you choose the RAM, you choose the memory, you choose the CPU, you choose the number of CPUs, you choose how many throughput, how much disk, and all the other things. And then gives you a lot of control over your computing environment, because you can literally build a high-performance computing environment, or you can just build something really super small and tiny to practice on, something you can dev and test against. So that's the neat part about Azure's virtual machines, is they're really flexible. You get to create it, you get to manage it, you get to own it. So Azure virtual machines can be used in various ways, and again, for development and test, this is a great way of basically practicing what you want to do, prove a point. Right, if you're going to go ahead and develop a specific product or specific thing, VMs are just a great way of spinning up whatever environment you need and going ahead and building what you need to build. And then when you're done, shutting it down for the day or killing it once it's done, or you've got it ready to go and to go into production. You can do that same thing in containers, but development and test environments inside of Azure are actually pretty nice. You can also do this for applications in the cloud because demand for your application might fluctuate. It may actually make sense for you to do this on your own VM rather than as a managed service. Or you may need to scale out more VMs and then scale in. So you've got that scalability and that elasticity. You can bring them up when you need them and shut them down when you don't. And you can also use these virtual machines just to extend your data center by using a peering or a virtual private network or some other way that you connect Azure to your organization's network. And it's a great way of saving money on your data center instead of trying to build out more heating, more cooling, build a bigger building, order more stuff. You would just literally extend your data center into Azure's cloud, which is a neat way of saving money. So the Azure App Service, and you ought to remember about this, is HTTP and HTTPS based service for hosting web applications. And you'll see that they talk about a lot of languages like we talked about earlier in this. You can use REST APIs, you can do mobile backends, you can develop in your favorite language. And that's the nice thing about this. Microsoft is enforcing you into a language. You don't need to do .NET or .NET Core. You can do the languages that you're comfortable with. You can do PHP, Python, Ruby, Java, Node.js. You can do all those things. So you don't have to revamp your development team or rewrite your application service to run within the Azure framework. The good part about that app service is it adds a lot of security, load balancing, auto scaling, and automated management. Depending on how you built it, you may actually have made it very cloud native, and that there are functions and processes and servers that when somebody does a thing, some code runs and something is given back to the customer. Right? You can also take advantage of all of the development and operations, DevOps capabilities. So you can do things within GitHub, Docker, other resources. You can do package management, staging environments, domains, and then set up your security for your SSL and TLS certificates within that. Right? With App Service, you only pay for the compute resources you use, right? And those are determined by the App Service plan that you run your apps on. And again, you're going to want to go back and take a look at that because that service plan will vary. So definitely go back and take a look at that app service plan. The key features of this, again, and we go back to, is that idea of multiple languages and frameworks. A managed production environment, right? They will go through and manage your patches and maintain your operating systems and language frameworks for you. The thing to remember, though, is that if you let them update your language frameworks, if something gets deprecated in the old one and you wrote against that old one, then your application may break. So you have to really spend time maintaining and updating your system and your software. Containerization and Docker, right? So remember, you're going to want to do a lot of containers, whether those are Windows or Linux. That containers in the app service allows you to just run multiple containers with multiple little tiny apps on them, and you can manage all of your Docker stuff directly in that app service, including your skills. DevOps optimization, again, you can set up that CI/CD, continuous integration and continuous deployment within Azure DevOps, GitHub, Bitbucket, Docker Hub, container registries, and then promote those updates through test and staging environments and into production. You can manage your apps in that app service either by PowerShell, command line interface. So there's all these different ways of doing this, but the neat part is that it really does help you streamline the idea to development to test to production development timeline. It really can help you out. The other key app service features of that is global scale with high availability. All right, you go global immediately. Connection to software on service platforms and on-premise data. You can choose from more than 50 different kinds of connectors for enterprise systems. Right, and that's a big one, right? Especially if you're doing something within Salesforce or you're doing something such as Facebook. This will really help you out on that one. Security and compliance. So we're all going to do all of our auditing and accreditation here for that. So ISO, SOC, PCI compliant. And those are big. Those audits are huge. If you ever get the chance, go back and check Cloud Computing for Business majors. They go a lot into ISO, SOC, and PCI compliance. Authenticate users with Azure Active Directory. You can use any one of those, Google, Facebook, Twitter, Microsoft. You can do IP address restrictions, manage service identities. All that's really handy within this. The other thing is templates, right? Sometimes sitting with a blank sheet of paper can really just stop development dead cold. It's one of those days. But you can choose from application templates to help you understand how to write something. You can work with WordPress, Joomla, Drupal, all those other kind of processes in terms of software, so you can start working right away on that. Now, other web app key features are Visual Studio and Visual Studio Code integration. So you've got that. So if you're already building in Visual Studio, you've got it. You're ready to go. API and mobile features. So you've got turnkey core support for RESTful API scenarios. And basically what that means is that you're ready to go. If you're using REST API, simplifies all of your mobile app applications and scenarios, gives you all that authentication, offline data sync, push, and everything else. So it's all there. You can basically be running serverless code, run a code snippet on demand, do a function as a service, and boom, you're up and running, you're doing your thing. So other things to consider besides app service, Azure offers other services that can be used for hosting websites and web applications. As far as Azure is concerned, the app service is the best choice, but there are some microservice architectures where you may want to use Spring Cloud Service or Service Fabrics, functions as a service. So, but if you really do need to have more control over the application that your system runs on, then go ahead and use Amazon Virtual Machines or Azure Virtual Machines along the way, just to kind of help you out there. All right, containers are really becoming the preferred way to package and deploy and manage cloud applications. Azure Container Instance offers their best way of doing that, right? So again, it's AKS, Azure Kubernetes Service. And again, that's a managed service. It's something you're going to work with. It's something that they're going to take care of all the back-end processes. All you've got to do is write code, and test, and deploy. So containers are significant startup benefits over virtual machines, right? You actually pay less because you're only working on compute resources. You're not paying for the whole virtual machine. The Kubernetes service itself is free. You're only paying a per CPU cycle. So that can be really different, especially if you're in dev and test. You're not going to have a lot of CPU cycles, but you can get a real feel for how many CPU cycles you're going to burn when you go into production. You can bring Windows, Linux, any kind of other images from Docker Hub into your private Azure container registry. And again, there's a lot of neat things you can do that go way beyond this test. So definitely check out the FAQ if you want to learn more about this. But just understand that Azure Container Instances will cache several common base operating systems to help you out. That Azure Container Service, Kubernetes Service, Azure Kubernetes Service is something that you're going to be working with as a managed service. Container access, pretty straightforward. You just need to have a full domain name, and you can go ahead and grab anything else you need from azurecontainer.io. Azure Container Instances also support executing command and running the container by providing an interactive shell. So again, you don't just need to be HTTP or anything else. You can actually use shell. You can actually use PowerShell or CLI, and then use TLS to secure those client connections back to you. And again, as your Kubernetes service, again, is that serverless managed service for CI/CD, right? For your developers, for DevOps. And again, your developers are going to be able to define, deploy, debug, and upgrade a lot of things that go along inside that Kubernetes service to get those applications up and running. The good part about it is that you do automate routine tasks, and you set up what's called a canary development strategy. So you can detect failures early. You can actually stack trace through. And again, these are all things you probably don't need to know about the test, but as you can trace and deep trace through your deployment, if you're a manager, this kind of service actually makes it a lot easier to track and trace how your spend's going, and also what your development timeline is going to look like. Right, so you can gain visibility into your environment. You can do telemetry, control plane telemetry, log aggregation, container health. I mean, all those things that you would want to measure anyways. So it's all there, ready to go within that Azure Kubernetes service. You can rely on built-in automated provisioning, repair, monitoring, and scaling. And again, you get started easily. It's a managed service. You're only paying for the CPU cycles that you use. You have an advisor system that's going to optimize and manage your deployment. You can save on costs by using spot instances, right? Because you may not need the whole thing all the time. Spot instances are really good. And then you get a lot of elasticity because you can add serverless power in a heartbeat as you need it because your application is scaling. And then there's another really neat one, and this is kind of one of those kind of sort of talked about but not really known. You just need to know that it exists, is the Azure Remote Desktop. And this is basically a way to get virtualized desktops and remote apps. And we're going to talk about a little bit more about how this works. So the desktop service framework, three main components: the remote desktop client, the service, and the virtual machines. These virtual machines are going to live on inside the customer domain, right? So they're going to live on inside of you, but you just get to use it. Part of the problem with it, though, is that as you go through your infrastructure build updates, you have to make sure that the agent update isn't connected to the desktop. So when you're using virtual desktop infrastructure updates, it doesn't mean that the agent might not update because of it. All right. All your VMs in a host pool may receive the agent updates at different times, so you'll need to be able to tell the difference, right? And you can go to your event logs and look for ID 3277, and that means the agent didn't update. And if the agent didn't update, then your remote desktop probably won't work the way you want to. They use something called the Geneva monitoring agent when they go. So the Geneva task is located and disabled before creating a new task for the new monitoring agent. And that's something else to remember in that desktop, is that there are specific things that your IT help desk are going to need to know. So you'll want to update your internal knowledge base for that. And then your VM will keep 3 versions of the agent side by side. And that allows for a quick recovery in case something goes wrong. So you have old agent, older agent, and then super old agent. And that will work. And if you delete these, then your agents are going to fail. But that remote desktop's really kind of neat, especially if you just want to have a thin clientless connection to your network and allow people to work that way. It's really kind of nice. So again, these are just some more services to know about. I didn't see a whole lot of questions on the practice tests for these, but you do just want to know, focus on the name and what they do, and any kind of error codes. You just need to know that virtual desktop exists, and it's just a neat way of doing clientless access to your network. All right, and this section is a bit more in depth, but you really wanted to understand why these services are being used. So that's the whole process behind this in terms of understanding why you needed to do this. But it is a neat thing. There's a lot of neat little services in there, and there's big reasons why you want to use them. So that's it for this lecture. I will see you in the next lecture. We're going to be in section 2.9. We're going to talk about Azure networks for this section. So essentially for this course, what you really need to just kind of understand is that there's a bunch of different kinds of networks, and this is how they interconnect. So you don't really need to know how to configure them. You just need to know what they are. So you do have virtual networks, and Azure calls them VNets. Azure Virtual Networks, and just basically another building block, right? Just like with everything else that's in the cloud, everything's a virtual building block for you. You can go ahead and use these to connect all of your Azure resources together, virtual machines, all of your apps, anything else that you've got cooking on in the background. You can use it for secure intercommunications with the internet and on-premise networks. VNet is like a traditional network. You kind of own it and run it, and you've got to make sure that you've got all of your network access control lists in place. If you have whitelists for IP addresses and things like that, it's kind of up to you because it's considered infrastructure as a service. So you just need to make sure that you're doing all of your configurations correct to make sure that it's secure. So some of the key scenarios that you're going to use in this is that basically communication with Azure resources of the internet. So, your gateway is how do you get out onto the internet? How do you provide service to customers through that whole process of setting up your networks? Communication between Azure resources, especially if you're doing a bunch of serverless computing, if you're doing function as a service, if you're doing anything that's API based back to other resources like payment gateways. Your VNet will help out. And communication with other on-premise resources, especially when they mean by on-premise, that's your database or your data center that you're going to be routing network traffic and integrating with other Azure services as you kind of go through. So the VNets are pretty kind of powerful when it comes to that process of it's basically your fundamental network. The VPN gateway, though, is a special type of network gateway that's used to send encrypted traffic between the Azure virtual network and your on-premise location over the public internet. So basically a virtual private network, right? And that's just basically a way to connect your data center to Azure. It's also a great way of connecting remote workers to Azure and all the other things that you would want to do depending on how you want to set this up. VPNs are pretty standard technology. It's always used to send encrypted traffic between Azure virtual networks over the Microsoft network and can be used to send your information over the network to the Azure network. Each virtual network can only have one VPN gateway, though. You can create multiple connections, but the limit is that per network, one VPN gateway. That's the important thing to remember. VPN gateways, though, when you configure your virtual network gateway, you can configure a setting that specifies the gateway type. The gateway type determines how the virtual gateway will be used. So gateway type VPN specifies a virtual network gateway created as a VPN gateway. This distinguishes it from what's called ExpressRoute. ExpressRoute is a different product here we'll cover here in just a minute, which is a different gateway type. A virtual network can have two virtual network gateways, one for VPN and one for ExpressRoute. So that's the big thing to remember on VPN gateways. You can have Express or you can have virtual private network. Peering, virtual peering. This is actually really kind of neat. It's where you're seamlessly connecting two or more virtual networks in Azure. So there's two kinds of peering in Azure. One is virtual network and the other one is global. So you're either connecting networks within the same Azure region or you're connecting virtual networks across Azure regions. This is a great way for trying to blend all of your systems together and doing specific peering between two different regions or two different zones, depending on what you need to do. So there's some real benefits to peering in terms of low latency, high bandwidth between resources in different virtual networks. And this is all software defined. The ability for resources in one network to communicate with resources in a different virtual network. And this is important if you're running health checks between different zones, if you're running health checks between different regions or region pairs, this becomes important, right? And I know if you're a traditional network guy, you're probably like going, this is the wrong kind of definition for peering. It's the Azure way of describing peering. So you can also peer from your data center to the Azure network, which is a different way of doing it, right? The ability to transfer data between virtual networks is huge. Azure Directory tenants, deployment models, and Azure regions. So this is really a key way of making sure that you've got some failover and some disaster recovery and some business continuity to go with it. You can peer virtual networks created through the resource manager, and you can, once they're done, you can do this through the classic deployment model and then go through that process. You may want to see the Azure deployment models on the website. And there's no downtime to resources in either virtual network. That's really all there is to peering. ExpressRoute is the other one we talked about earlier. It lets you extend your on-premise network into Microsoft Cloud. So ExpressRoute basically takes your data center and connects it to the Azure cloud. And that's the important part with that VPN gateway bit, right? Depends on what you're doing. And you can also do it for Microsoft Cloud services such as Azure Office 365. I don't see this so much in terms of Microsoft 365 services unless it's something like Dynamics, something where you need to keep your customer data kind of quiet and private and all the rest of it. But this is just another way of doing it. So ExpressRoute is kind of neat if you want to tie your data center directly or you want to tie to specific Azure services. Right? Connectivity can be formed to any, right? Anyone can connect, point to point Ethernet network or virtual cross connection. And that's something that your network engineer will set up for you. So this allows ExpressRoute connections to offer, more reliability, faster speeds, consistency, and all the other things. So you can make sure that your ExpressRoute connections don't go over the public internet. It's basically a virtualized tunnel over the internet. So you're not just sending packets willy-nilly, you're actually building yourself your own little tunnel. It's a layer 3 connectivity, and that's between your on-premise network and the Microsoft Cloud. It's connectivity to Microsoft Cloud services across all regions, global connectivity to Microsoft services, dynamic routing via BGP, which is important if you're going to set up some networks. And when you go deeper into Microsoft, you'll cover more about how to route on networks, built-in redundancy, connection uptime SLAs, and quality of service support or Skype for Business. So there's a lot of neat things that you can do with ExpressRoute, but it really is a nice way of tying your data center to the Microsoft Cloud. So there are multiple ways to connect to the internet via Azure, the VNet, the virtual network, Azure virtual network, the VPN gateway. Remember, there's two, ExpressRoute and regular gateway. Network peering, either virtual or global, and then the ExpressRoute to kind of get you through the day. And that's kind of it for networks. It's really generic and really teeny tiny. There's not a whole lot here you need to know about on the test. You just need to know that there's different kinds and what they are and what they do. And I will see you in the next lecture. Z900 Azure Fundamentals Part 2.10, Storage. So storage is pretty fundamental to anything you're going to do on the internet. You're going to need to have different kinds of storage. You're going to know how those storage tiers actually work, the way that they store data and duration of data storage, file storage, disk, and container. So we're going to kind of go over those storage systems as we go through this lecture. This lecture is kind of just a really generic one. There's nothing really overly complex here in terms of that. But you do have a core service, which is the Azure Storage Platform. And that's your cloud storage solution for modern data storage scenarios, as they put it. So there's a bunch of core storage services that basically gives you the ability to scale object store for data objects, disk storage for virtual machines, and a file system service for the cloud, as well as some messaging storing for queuing and then a NoSQL store. So these are the kinds of things that you're going to be running into in the storage platform. So overview is basically the idea is that this is durable, highly available, four nines, all the whole 9 yards on this. It's secure. Everything can be encrypted either by you or by using Azure keys through the key management process. It's scalable. You just throw your data up there and it grows the way you need it to grow. It's managed. So Azure handles all the maintenance and everything else. You're basically just buying disk space and you don't have to worry about managing it or buying more. It just will automatically grow with you. It's accessible. You can basically get to it anywhere. There's also a whole bunch of client libraries that you can use, .NET, Java, Node, Python, PHP. And this is really, really good, especially if you do a website on storage. So if you do something in storage that allows for streaming, you have a lot of video, you do a bunch of other stuff that's consistent static content, this is a great place for your storage platform process to keep all your costs down. So really it's a good thing to have that managed. So there's some core storage services you really want to look at, and that's going to be Azure Blobs. Blobs are great. They're massively scale objects. They're basically text and binary data, but they're huge, right? They're video, they're audio, they're machine learning training data sets. So they can be anything that's through that. You can also support big data analytics and use your core storage for blobs to process for data lake storage. Azure Files, manage file shares for cloud or on-premise deployments. Azure Queues, and this is interesting because it's a message store for reliable queuing between application components. So this is important if you're doing function as a service, you're doing serverless, you're doing containers, you've got stuff that works on messaging, that having the ability to store and forward these message queues depending on how bogged down things are, which they shouldn't be. Then you have the ability to store messages in queue, or you have the ability to track and trace those messages through. Azure Tables, basically a great place to store all your NoSQL store for schemaless storage of structured data. As we talked about earlier, things like shopping carts and things like that would work really, really well here. And then Azure Disks, which are block level storage for Azure virtual machines. So those are your basic container services, and this is what you really need to focus on, is what are they, what do they do, how do they work? There's 3 different kinds of storage tiering and how long your data can survive or how you're going to get charged for data storage. For hot tier is an optimized storage that's accessed all the time. So if you're running a streaming movie service like Netflix, just about every video you've got is going to be hot tier. Right? It's got the highest storage costs, but also the lowest access costs. So it's something you're using every day. Cool tier is for stuff that's over 30 days. So if you've ever heard the phrase the long tail, usually whenever data is put on the internet first, it really spikes and it's really hot and everybody wants to look at it for the first 30 days. And then after that, it just kind of goes away. People don't look at it as often. It's not referenced as often as it should be. So basically, cool tier allows you to kind of save storage costs based on that long tail concept of that sudden spike, and then usage gradually tapers over time. And then your archive tier, an offline tier optimized for storing data that's rarely accessed. So let's say you only need to access data once a year, and then you need to store it for 7 years. Then your archive tier is great. You really just want to store for a minimum of 180 days. So that's the thing to remember. Hot tier is today, cool tier, minimum of 30 days, and then archive tier, a minimum of 180 days. There's some kind of interesting capacity limits on this, right? As you kind of go through and you take a look at how they did it on the table. The availability is always going to be like 3 or 4 nines. The interesting part though is that on cool tier, it's only 99% for availability. Right? Lower storage costs, but higher access transaction costs. Everything is milliseconds except for archive can be hours, and then supported redundancy. Then you've got to make sure that in your archive tier that you've actually got some really good backups going somewhere for this just in case. So that's a really important part to remember, is that the availability is between 2 and 4 nines, depending on what you got. Hot tier is the most reliable. Cool tier is okay. 30 days, 80 days, milliseconds, hours for your archive tier. That's the important thing to remember on those storage capacity limits. So the big thing to remember on your summary is that blobs are great. All right, massively scalable object. It's text, it's binary data, it's learning data, it's everything you would want to have. Azure Files, manage files, shares for cloud or on-premise deployments. Amazon Queues for messaging between application components. Azure Tables, NoSQL store. Azure Disk, block level for Azure VMs. And then remember your retention times and percentages for the test. So I want to thank you for being in this lecture, part 210 for storage, and I'll see you in the next lecture. 900 Part 211 databases. This is kind of a quicker section just because there's not a whole lot on the test or in the study guide for databases. It's really more about what are they and how they work. So basically you've got choices of fully managed relational, non-relational, NoSQL, in-memory databases. It basically covers just about everything you would ever want to cover. It's a really, really, really detailed section of just stuff that is available through Azure. A lot of it's driven mostly just because of the way modern businesses run right now, is that a lot of our content that's delivered is dynamic. So databases really do perform a lot of the basic functions that we have on the internet now. So the big thing to remember is databases by what they do, right? So if you want to manage intelligent SQL in the cloud, you want Azure SQL database. If you want a managed, always up-to-date instance, then you can actually just go managed instances. So the big difference is the database, you own it, but the managed instance is that you just own the table. So that's what's neat about that, right? You can actually either go for the whole database or just go for specific tables. You can actually go for owning your own server on a virtual machine, and that's SQL compatibility across the operating system. And that's in case you need that, right? That's just a thing. If you can't use the basic inbuilt database and you need to actually have functionality at that database level, then you'd go with that one. So build scalable, the Azure database for Postgres SQL, right? And that's Postgres SQL and Oracle workloads. So basically high performance, but that variation. Azure database for MySQL, the open source community, they do use the enterprise version, so it's kind of neat. They also have a community database service as well. So MySQL, that's just a basic backbone that's used by just about everybody for some reason or another. It powers WordPress along with MariaDB. MariaDB is just an offshoot of MySQL, so it's a really handy thing to have. And then this really nice though is the one that Azure built as your Cosmos DB for NoSQL, right? So Mongo, Cassandra, you can actually migrate your NoSQL to Azure Cosmos DB, and that's as a managed service. It's a really neat thing to use along the way. And then there's Azure Cache for Redis. So people who need to have an in-memory data store are going to be using Redis or going to be using Memcache or some other process like that. The one for Azure is Azure Cache for Redis. And it's just a neat service. Again, if you need something that's high open source compatible with in-memory data store, you're storing data temporarily, this is where you're going to want to go, especially if it's commonly used data, things that people are asking for all the time, like a leaderboard, then this is perfect for it. There's your database migration service. I've seen some test questions on this in terms of practice exams, right? So they're going to want to know that you know how to transition data from one on-premise database to an Azure database. And it's going to be the Azure Database Migration Service that will do that work for you. It's self-guided, it works, it's really super easy to do, and it helps you pick out the right database to do the work that you need it to do. Then finally is your managed instance for Apache Cassandra. So Cassandra data clusters, it's basically, you get that ability to run huge data clusters with that, and it's a neat managed service that uses open source Apache Cassandra. So those are basically the databases you're going to want to remember, but the big one is going to be Azure SQL, Redis, Database Migration Service, and MySQL, and Cosmos and Cassandra. Those are going to be the big ones, at least from what I can tell from the practice test. Right? So Azure SQL managed instance, and this is kind of interesting because it's a scalable cloud database service, and it's really broad, right? It's just a server database engine. It works, it does the things. It's 100% compatibility or near with any SQL server, including their own, right? You've got a Microsoft SQL server. It provides a native virtual network implementation. It covers all the security systems and every concern that you would have there. And again, it's a business model is favorable to current SQL customers. So if you're already running Microsoft SQL, then you'd probably want to go with an SQL managed instance, right? And allows existing SQL customers to lift and shift their entire on-premise data applications to the cloud without having too much of a fuss. So you may see a bunch of stuff about the SQL managed service, and it's basically lift and shift your entire database over. So in summary, do remember the table of database types in the Azure solution. And it's just the general knowledge that's needed here. You're not going to need to know how to configure or build or anything else. There might be some scenarios on data migration, at least there have been in the practice tests I've looked at. So refer back to that section about data migration services if you need to. And that's it for databases. Again, not a whole lot that you need to know here in terms of detail. Just know that you've got a bunch of really generic databases that you can work with. So that concludes this lecture, and thank you, and I will see you in the next lecture. Just about it for section 2, and we have powered our way through a good chunk of data, a good understanding of all the core services and everything else that Azure can bring. And this one kind of brings it home. This is the final bit, and that's just the Azure Marketplace. And this is a really teeny tiny thing. It's not a huge amount of data on it, but it is kind of a neat thing. And that the Azure Marketplace is basically where you can buy solutions from someone else. If you don't want to make your own solution, you can buy it. You can find someone that's already made it for you. You can go ahead and buy it or rent it or however you want to go ahead and use it. And the Azure Marketplace is where you can go and find all the neat things that other people are doing. So the interesting part, though, is that there's everything in here. Solutions for different industries, technical areas. There's free trials if you want to try something out. Consulting services for Microsoft partners, open source, proprietary. There's everything in here. So it's kind of like this huge bazaar of stuff, right? But there's 3 different kinds of previews that you do need to know about. And that's the private preview, and that's where a few customers, really good customers, take part in early access to new concepts and features. There's no support or anything else for that private preview. The public preview is that you really do kind of want to go ahead and allow any customer with the proper Azure to evaluate the new feature. So they're kind of not supported, but they kind of are supported. You can expect these services to go away if they're not super popular, right? So I wouldn't build my business on public preview, but it is just kind of a neat thing to learn about new features that Azure is thinking about bringing or will be bringing on later on. And then generally available. This is where everything is ready to go. All the public and private previews are done. The feature is open for any licensed customer, and it's always supported. So be aware when a new feature impacts that existing functionality, it might change the way you or your users use that functionality, but it should be underneath generally available, and there will be some support that goes along with that. So again, so just remember your 3 preview types: private, public, and then the generally available. And that kind of closes out this marketplace. Again, a very quick section. Just remember your marketplace types: public, private, and generally available for the exam. And you should be good. And thank you for sticking with me all the way through section 2 Azure Core Services. This has been a lot of stuff to dig through. And we've got 3 more sections to go: part 3, part 4, and part 5. And we should be just fine. But thank you for paying attention, and I will see you in the next lecture.